As a physical scientist and an engineer, I tend to think about the consequences of climate change in terms of the physical processes of the Earth. So things like temperature, the fact that there'll be no glaciers. For Europe, this is particularly important because many of your rivers derive from melting glaciers. And if the rivers become seasonal, then many aspects of your culture and life change. I think some of the bigger problems have to do with ecosystems. Scientists have already been studying changing ecosystems, one of which I find very interesting is the rate at which an ecosystem is moving in time. So for example, the transition between birch and pine in the mountains, that's very sensitive to climate change. And as we get warmer, that birch-pine transition moves. And right now, they are moving faster than they ever have in recorded history. And so one of the other things we're going to see with climate change are these unexpected changes in ecosystems. So what was exciting about recent studies from climate scientists and atmospheric chemists is by measuring how much light is emitted from the Earth and how much comes in, they can actually measure the thermodynamic forces that change the temperature of the planet. And they find that those forces match exactly the changing composition of CO2 in the atmosphere. So this, I think, is the first real direct link between what we call radiative forcing, which is how the absorbing CO2 forces the planet to change its average temperature. The International Panel for Climate Change and many other bodies have said that capturing CO2 from coal-fired power plants is an essential component of mitigating CO2 in the atmosphere. And I'm working on that actively, and I feel that's a very important area. I think we need to think very broadly about decarbonizing the atmosphere. And if I may invoke someone very different, which is the Pope, who talks a lot about consumption and how particularly Western cultures, but I think all of us tend to overconsume, and overconsumption leads to overproduction, which leads to loss of efficiency, which increases CO2. So a mindset about being methodical and careful about consumption, so that what we do buy is what we want to buy, what we do buy is sourced sustainably, that it is born of elements of the earth and dies of elements of the earth, that process is completely understood by the consumer. This could make a huge difference in the CO2 impact.
Professor Reimer is probably one of the most prominent chemical engineers in Berkeley. I know him for probably 3 decades, and because we work in the same field of research, nuclear magnetic resonance. And he is just a very excellent lecturer. He has received many prizes for his teaching skills. And also because the topic is of interest. In Berkeley, they've taken the initiative to address climate change by putting together a new course to look at the basics, at the scientific basis, what is the evidence, and what is the chemical engineering approach about issues of finding remedies, or what is the magnitude of change involved, and how can we address that in a scientific way.